Hi, this is Selvapriyan. We are going to see 2009 Transportation Engineering problems. First question, the value of lateral friction or side friction used in design of horizontal curve as per IRC. So in question it is lateral friction or side friction is asked. So answer is 0.15. Lateral friction is used in the calculation of super elevation, whereas longitudinal friction is used in calculation of side distance. Next question, during CBR test, load sustained by remodeled soil specimen at 5 mm penetration is 50 kg. The CBR value. So CBR value is equal to formula is equal to load sustained by specimen at 5 mm penetration divided by load sustained by standard aggregate. Here load sustained by specimen at 5 mm penetration is 50 kg and by standard aggregate it is 2055 into 100 percentage. It will be equal to, after calculation it is 2.4 percentage. If in question 2.5 mm is given instead of 5 mm penetration, if 2.5 mm is given, load sustained by standard aggregate will be 1370 kg. For 5 mm penetration it is 2055 kg. For 2.5 mm penetration it is 1370 kg. Next question, for which of the following stress combinations are appropriate in identifying the stress critical condition for design of concrete pavements? So we have to identify the critical condition. For load stress, the critical condition is at edge, and for temperature stress, the critical condition is at interior. Answer is 2, 3. Option A is the right answer. Next question, the crest vertical curve joins two gradients of plus 3% and minus 2%, ascending and descending. Therefore, it is summit curve. Descent speed is given, v is given, that is 80 km per hour, and corresponding stopping side distance is given, s, that is s is given as 120 meter. Height of driver's eye and height of object above the road surface is given, that is 1.2 meter and 0.15 meter. This is capital H and this is small h. Curve length to be provided is L, we have to find out, and one more condition is given which is lesser than stopping side distance. So L is lesser than S. Therefore, the formula will be L is equal to 2S minus root of 2 into capital H plus root of 2 into small h whole square divided by N. Capital H is 1.2 meter and small h is 0.15 meter. So it will be 2S minus, after the substitutions it will be 4.4 divided by N. Is equal to 2 into 120 minus 4.4 divided by N is equal to 3 percentage minus of minus 2 percentage. So therefore it will be 5 percentage. Substituting, we will get the answer as 152 meter. 152 meter is the answer. So option B will be the right answer, but it is not, because in question it is clearly mentioned L should be lesser than S. But we arrived the answer that 152 meter is larger than S. So our assumption is wrong. L lesser than S is wrong assumption. Now we have to consider L greater than S. Now the formula will be changed to n square divided by 4.4. This 4.4 is nothing but root 2h plus root 2h whole square. So it will be 5 percentage into 120 square divided by 4.4, and now we will get the answer as 163.64 meter. Therefore, option C will be the right answer. Next question, on a specific highway, the speed density relationship follows Greenberg's model. V is equal to Vf into logarithmic Kj by K, where Vf and Kj are free flow speed and jam density respectively. When the highway is operating at capacity, the density obtained as per this model is. So the density will be, that is K is asked in question. So density is equal to nothing but K is equal to Kj by E for Greenberg's model. So option D is the right answer. Now look at the option C, that is Kj by 2. Kj by 2. Can you remember this formula? Yes, we have seen this in previous video. That is K, that is traffic density is equal to Kj by 2. That is jam density divided by 2. And this is for green shield model. But in question, they have asked for Greenberg model. If they have asked for green shield model, sorry, this green shield model, the answer will be Kj by 2. We have seen that formula, that is Q max is equal to maximum flow is equal to Vf by 2 into Kj by 2. Vf by 2 is equal to speed at maximum flow, and Kj by 2 is equal to traffic density. This answer K is equal to Kj by E is arrived by differentiating that V, that Q is equal to we all know that Q is equal to V into K. So Q is equal to V, that is Vf into logarithmic Kj by K into K. So we have to differentiate this, that is dq with respect to dk is equal to 0. After differentiating this with respect to density and equating this equal to 0, we will get this answer, K is equal to Kj by E. So last question, a three-phase traffic signal at an intersection is designed for flows shown in the figure below. So at this intersection, a traffic signal is to be designed. The three-phase traffic signal is to be designed. There are six group of flows. Identified by numbers 1 to 6. Six flows are given from 1 to 6. Among these, 1, 3, 4, and 6 are through flows. So through flows. What is meant by through flows? It is a straight flow. So 1 is from north to south. Sorry, south to north. This is a through flow. And the 3 is a through flow, that is from east to west. 6 is from north to south. And sorry, 4 is from north to south, 6 is from west to east. So these are through flows. And 2 and 5 are right turnings. So 2 is right turning, that is u turning. This is turning like this. And 5 is also right turn, that is this is turning like this, u turn, simply u turn. Which phasing scheme is not feasible? So we have there are four combinations given here, P, Q, R, and S, and for those four combinations, phase one, phase two, phase three is given. So we have to find out which phasing scheme is not possible. So before moving on to that, now look at this diagram, which is not possible. If you look at this diagram, 1 and 3 can't move exactly at the same time. So if 1 and moves if 1 and 3 vehicles vehicles at 1 and 3 moves exactly at the same time, there is a risk of accident happening here, because there is a crossing here. If 1 and 3 move simultaneously, there will be an accident because there is a crossing here. So 1 and 3 can't move simultaneously, and like that 1 and 6 can't move simultaneously, 1 and 3 can't move simultaneously, 1 and 6 can't move simultaneously. Similar to that, 3 and 4 can't move simultaneously. Look at this. Look at the crossing here. There is a crossing here for 1 and 3, and for 1 and 6 there is a crossing, and for 3 and 4 there is a crossing here, and like that 4 between 4 and 6 there is a crossing here. So these four combinations can't move exactly at the same time. So 1 and 3, 1 and 6, 3 and 4, and 4 and 6. If any of this occurs at this phase, that is not possible. Now look at P, 1 and 1, 4. So 1 and 4 can move simultaneously. There will be no problem. 2 and 5 can move simultaneously. There will be no problem. 3 and 6, it is possible. So combination P is possible. Now look at Q, 1 and 2, it is possible. 4 and 5, it is possible. 3 and 6, also it is possible. They can move simultaneously. There will be no problem. There will be no risk of accidents. Now look at R, 2 and 5, there will be no problem, it is possible. 1 and 3, so 1 and 3 is not possible. Between 1 and 3, there is a crossing here, so there is a probability of accident. So 1 and 3 is not possible, so R is not possible at all. So phasing scheme R is not possible, therefore answer R is the right answer. No need to look at the option yes. Now look at Case 3 of R, it is 4 and 6. 4 and 6 is also not possible. So 1 and 3, 4 and 6 is not possible. So option R is the right answer. Now look at option S. For our satisfaction, we are looking at yes. 1 and 4, it is possible. 2 and 6, also it is possible. 3 and 5, it is possible. So there will be no problem. So that's it for today. Tomorrow, let's see 2010 transportation engineering problems. Thank you.